Alright, going to go ahead and cover the PfSense installation. Going to go ahead and do this for the management area. So when you install your VMware environment, it is heavily dependent on DNS. So pretty much all of your ESXi nodes, your vCenter, your NSX edges, your NSX controllers, vRealize automation, orchestrator, all of those depend heavily on DNS to the degree where if you do not have, at the very least, a host file set up, your system will just start collapsing. For things like vSAN, you absolutely have to have it in there so that your vSAN can start up properly. One of the big deals with this is that you want to make sure that your DNS can start without anything that would rely on DNS, meaning that normally you would not put it onto something like vSAN. So let's go ahead and let's get started on this one. We're going to go ahead and do a new virtual machine. And we'll call this guy DNS01. And we're going to put on ESXi master. For that, we can go ahead and do the local on here. Compatibility, we're just going to go with whatever version. Guest OS is going to be other. We are using PfSense, which is a BSD kernel. So we'll go ahead and do FreeBSD. And for the hardware, 2 CPUs is more than enough. 8 gigs of RAM is definitely more than enough. And giving it 12 gigs on a hard drive basically covers anything that you really need to worry about with logs and things like that. So because we're installing PfSense, that is actually meant as a firewall router. So we're going to go ahead and add another network device. We're going to go ahead and disconnect this one, and we are going to go ahead and put this onto VLAN 10. So as far as the CD DVD drive, we're going to go to the content library. I've uploaded PfSense into my content library. You could also put it onto a data store, just drop it on there, or you can go ahead and have it as a, if your machine has a CD DVD tray, you can go ahead and put it there. And DNS01, we go ahead, hit go on it. And this is going to be a whole lot of next finish initially. So starting from inside of here, we'll go ahead and let's close that out. Take a look at the installation. I'm going to run through a few different pieces here while it finds all of the hardware. We're going to go ahead and accept, tell it to install, and should move incredibly fast. The BSD system is very similar to Linux in its POSIX compliance, but BSD in general has been used for appliances pretty much across the board. NetApp is based off a BSD kernel, or at least it was last time I worked with it. So there we go. We do not need to make any more changes, and we'll go ahead and reboot this guy. And one of the things we can go ahead and do is we can go ahead and check see what we have free. It looks like we've got 92 and 91 free. Now I am setting this inside of my virtual environment, so we're going to go ahead and say no, we're not setting that up. We're going to go ahead and set the VMX0 as WAN and VMX1 as LAN. Alright. Because this is internal to my virtualization environment, which is somewhat segregated from my home network, it's got its own little switching environment over there, and I have not shared all routes between. I'm going to jump into a VM for configuration on this. So the key to what we're doing right now is setting up DNS in this environment, but what we are using with PfSense is in general a firewall or a router. So we will be making a lot of security changes for this, and then we're going to loosen a lot of security, and then I'll show you how to retighten it. So we'll go ahead and set the interface for the LAN, and that is going to be 10.10.10.92. We're going to be using CIDR notation, so 24 for a Class C. And for the upstream, because we have disconnected the WAN, it'll be 10.10.1 or 10.10.10.1, and no IPv6. We don't want DHCP. Not worried about the web configurator. And there we go. So now we have the ability to get over there. Let's go ahead and bring this to full screen. Let's see. There we go. Oop. Let's go ahead and go in. It starts off with its own self-signed certificate. On install, it is going to be admin PfSense. And it takes a minute for it to get everything up and going. So we'll want to change the password here. And we'll change it over to our standard system here. Normal password for the dev environment I have here. And we go ahead and save it. There we go. So now we have the ability to log in with our own unique password. You can go ahead, if you really feel like it, adding users and groups in here. Completely unnecessary if you're just doing this for DNS. There are some places where you would want to do this. Most commonly, you would want to set up a user if you're going to start pulling individual files off of this system. And there is a reason why you would want to do that. So when we're talking about the services here of the DNS resolver, what it's using in the back end is actually an application called Unbound. Unbound you can install on Linux installations as well, and there is a way to containerize it. But if you're setting everything up and you got this nice pretty graphical interface, go ahead and go this route. And if you want to set up a very small version, you can pull your configs, modify them to fit the environment, and put them into a container or into a configuration on a host. So first things first, let's take a look at the firewall. So one of the big important things here is on this LAN, it only wants to communicate with things that are on the LAN network here. Okay, so we can change that around. We can go ahead and edit it. So you absolutely cannot edit this being able to get to this web page, from that LAN. So you should always be able to reach this provided you're plumbed to it. And they show in here that's an anti-lockout rule. So you should always be able to get to your config from the LAN. Now this piece right here, this is what we're going to change. We really want to make sure that we can get any in there, because when we start doing DNS lookups, we don't want it to block. So, and save that, apply the change. So that's going to go ahead and run. Once it's done, we go ahead, get into the DNS resolver, and we're going to go ahead and look through here. We've got the ability to enable TLS service, which is, DNSSEC type stuff. So because of the way that we're doing this, the integration in with your management plane, with your control plane, it probably isn't in your best interest to enable that and use it. Your interfaces, we're going to want to make sure that all interfaces, because we only have the two, the WAN and the LAN, are able to perform DNS queries and lookups, all that good stuff. So the DNSSEC support, we don't need that. We can leave it enabled because that means that it is able to perform DNSSEC. And then let's keep going up. Inside of the advanced settings is where we start getting into some of the privacy options. So some of this you may want to remove, depends on what it is that's in your management plane. We probably would turn that off. There's a few pieces and parts in here. And once you change the security inside of these advanced settings, you'll have to apply the changes again. When we get into our access lists, now this is a really important one. This is how you're going to be able to reach from different networks over into your DNS to perform queries. So right now I'm on a system that I believe is a 10.10.2 system. So if I were to go inside of here and say, local area, we want to allow, you can enter a description. We're going to go 10.10.2.0. and that'll be a Class C subnet, so this is all CIDR notation, and we can add another description there. We can also add another network here. We can do 10.10.10.0, so anything else that's on its local network can perform a query. And we save those, apply the changes, and now we can perform queries from 10.10.2 and 10.10.10. Our general settings, we can go ahead and get down in here. This host overrides is actually, this is your file for DNS. So we get in here, we're going to do a vcsa at verizon.net. So that is our vCenter server. Now the funny thing is that the system automatically picked verizon.net based on what the domain leached from its DHCP from my internet provider. So kind of funny there. I believe our vCenter server is 10.10.3.10. Yeah, that's correct. So we're going to do 10.10.3.10. Now, so you don't have a lot here, right? You've got your host name, your domain name, your IP address. So this is going to be an A record and a reverse lookup. That's it. You don't have C names. I mean, this could kind of be a C name, so no canonical names, and no real serve record. So you're not going to be putting in, DNS serve record, letting the entire network know that you're performing DNS. So Unbound is very basic as far as things go, but it works for what we're trying to do here. So this is 10.10.10.92. So from here we should be able to perform an NSX lookup of vcsa.verizon.net at 10.10.10.92. And there we go. Querying that server, we were able to find the address. So that means that this is working. So let's say you've filled this out. You've got 20 or 30 addresses in here. You've got all of the configuration done, and now you're worried about how you back this up, right? So you've got your working environment. You are going to want to make sure inside of our diagnostics that we perform a backup. So the backup area is all, or you can start getting down into here, right? So I just want to back up DNS resolver or firewall rules or any of that stuff, right? We can back up packet information. I believe this RRD, that's I believe some type of log data. I'd have to double check that. And we can encrypt this. So I believe when we click this, yeah, it asks for a password. So if you wanted to go ahead and have a little safe backup, go ahead and encrypt it. We download as an XML, save the file. It downloads to this host, and then let's get into our downloads. There it is. If we needed to recover a new build, just make sure that you have everything configured the same, network interfaces, all that good stuff. Same amount of CPU, same amount of RAM, same amount of disk area, and then you can go ahead and restore all with that configuration file. All you would need to do is make it so that you can get to the management screen and you'll be able to perform a configuration. The other nice thing is if you're trying to recreate an environment, so you've got a cookie cutter stamped out environment, you can go ahead and recover across all of your environments that same file, because as long as they're separated air gapped systems, it shouldn't have any effect. You'll just always have your DNS and be able to recreate it out of your recoveries. So that is the basic there. That's the installing PfSense, getting it up and running, making sure that you have your DNS working, making sure you have the security settings appropriate so that you can actually perform a query, and then how to back up and recover. So the next piece that I'd like to cover is actually the nice little piece in here for high availability synchronization. So what we're going to go ahead and do here is we're going to go ahead and build a secondary. We're going to go ahead and have a new virtual machine. This one will be DNS02. We'll go ahead and put it on node 02. For this one, we're going to go ahead and put this on the vSAN. We could put it on, any of these three. These are all NFS. I believe these may also have a requirement for name resolution. Realistically, if you were to put out two of these, they would both be going onto local storage. Make sure that you're not dependent on DNS on your DNS server. And once again, we'll go ahead, go with that. 2, 8, and 12. And we'll go ahead and add that network adapter, disconnect that guy, put this one onto the correct VLAN. And get another installation of PfSense going. Alright, so DNS02 is built. We roll it. Might do a little movie magic here and get it so that it's just running through this. Alright, finished our build. We're going to go ahead and do our first time boot, see what we can get going here. Alright, so I'm not going to set any VLANs in here. And VMX0 is our WAN, VMX1 is our LAN. And as soon as this comes up, we can go ahead do our return over with IP configuration and then see if we can set up our high availability. So let's go ahead and set the IP interface here for the LAN. And that's going to be 10.10.10.91, CIDR 24, 10.10.10.1, nothing, no, no. Alright, so there we go. Now we can get right back inside of here. We can go ahead and go to 10.10.10.91, and there we go. We'll go ahead and change over our password to our devlab password. And we'll go ahead and save that. Alright, so now we're going to go ahead and go back to this guy. We're going to take a look at high availability sync. We're going to sync on the LAN to 10.10.10.91. Okay, so let's see. And 10.10.10.91 again. Let's see. I may need to back this one out. There we go. I believe this is the one we're going to configure it to. And we'll go ahead and do our password here. And of course, down at the bottom, we've got a toggle all. Hit save. Alright, so I'm not 100% certain about this as to how exactly this is going to work. Whether or not we're going to get an immediate response here, or it looks like we do. Yes, so as soon as we set that up, we now have a high availability. So this is our capability right here to perform a high availability synchronization. So now we have 10.10.10.92 and 91 both set up. They've got the same configuration, same security settings, created the local area access list automatically. So that is an easy way to get everything synchronized over between these two. So in general, what you're going to want is, you want to have your failover. Oh, I lost my one DNS. Okay, well, you have your other. So this is how you end up with two DNS servers with the same configuration settings. Now, keep in mind that when I did that, there was the same layout on the WAN and LAN. And if you end up with 5 or 10 interfaces, you're probably going to want to have 5 or 10 interfaces that require the same synchronization. So going over to the same environments, all that good stuff. Now, let me go ahead and cover one other thing here. I brought up how you may want to set up a user so that you can use SSH and you can move files off and on. Right? So the reason why is when you have the DNS server set up, you've got this unbound. Unbound is the application for your DNS, and these are all of its config files. Now, there's nothing in that conf.d file. Not a big deal. That's, I'm sure there's some other type of configuration that can go there, or you can go ahead and probably copy all of these and put it in there. This may just be a remnant of BSD versus Linux. So when we look at the access list file, you can see what our access control is. So you can see there at the top of it that we're all that 127, so your home address, and then right below that the local area, the two network segments that we put in there. So both those class C addresses with the allow. If you were to do this in Linux, you could go ahead and open this up in VI. copy an access control down there under local area, modify it, and then restart the unbound service, and you would now have that access control taken care of. We do not use DHCP here. We're not using any domain overrides. Our host entries, though, there we go. So we can see what our host entries look like here, right? The local host, local domain, 127, blah, blah, blah. Down there, though, that 10.10.10.91 showing that it's PfSense local domain, and then that 10.10.3.10, the VCSA Verizon.net. So it's not showing the A record going to the reverse lookup. So you've got the pointer and you've got the A record. Those are the two type of DNS files that are created, and they're just right here. So, in general, when you're looking at something like Active Directory and you've got your DNS window open, you've got to go ahead and create your host name. You've got to make sure that you have the reverse lookup zone, so the network has to be set before you can utilize it inside of DNS to set the IP address and host name inside of your DNS settings. It's considerably more simpler here, where you just have the pointer record and the host name. So good stuff right there. We can also look at the remote control configuration. So it is allowing you to control unbound externally. We've got these keys in here. That is most certainly something that you're going to want to make sure is set up where you build it. I believe the exception to this rule may be if it's containerized and you have something like Vault running where you're able to create your keys. So then our unbound configuration itself. And I'm hoping this isn't insanely long. Yeah, it's still pretty long. So let's go ahead and take a look at that. All right, so it shows that we're a server, and it's running inside of var unbound. In Linux, that would be etc unbound, and showing all of the different settings here. So username, directory, what port it's using. These are, all of those settings that you saw when we were on those security configurations pages. We have those are all in here and present. So they're showing our certificates, which interfaces to bind to for unbound. So 0000 means all interfaces, and that's on IPv4 and 6. You can see with that ::0 there, that's IPv6. Our DNS rebinding, this is, you can see all of the private addressing that would normally happen, and then that 169.254, the APIPA addressing. So those are in there, preventing basically the ability to close yourself out of your own DNS. So inside of our access list here, we have the location of that comp file, same with the host entries and DHCP leases. So like I said, on Linux, that would be etc unbound. That would be the location of those. So it's kind of funny, you have a config file that's full of config files. It's kind of the way I'm looking at this. So this is the main, how the application starts, what other configuration files it needs to start, and then of course up at the top what user should be starting it and all that good stuff. So you may want to copy over, if you create these large intricate host files and access files, you may want to copy those over and SFTP them or SCP them over to another server so that you can start up maybe a Linux version or a containerized version of Unbound. That's just one of the reasons why I would recommend setting up a user that has the ability to SSH at some point. And then also, of course, when you're inside of your system here, you can turn off and on a lot of different services and close them off through the firewall. So you could go ahead and firewall, set up a rule, and updated everything. You can go ahead and set up your rules for your LAN and tell it to go ahead and drop all SSH traffic, and then when you need to move files off and on, you can go ahead and re-enable it. So I want to say that we can add a rule to the bottom of the list that we block or reject. So blocking just means that the packet is going to look like it's dropped. Reject means you're actively going to tell the other system that you are rejecting it. On the interface, protocol, let's see, yeah, so you can do TCP/UDP. So we can do a few different things in here. We can do the any source, and then for the destination, we can go ahead and create any destination. Pop in here. I believe SSH should be available. There it is. So we create this rule. So IPv4 and IPv6 on trying to get to the LAN using TCP or UDP. Of course, SSH is going to be TCP. It'll block port 22, and we can log that happens. Save that, and there. Now we are blocking anybody that tries to SSH into the system. Apply the changes. You would not be able to SSH in. Now, this is all contingent on actually having users that are able to SSH. But that is a quick and easy rule to allow you to set up those users and disable the rules as needed. I believe this guy right here, we can, disable, and then if it's disabled, then we can enable. So, alright, and that is configuration of DNS for your control plane with replication over for high availability and the backup and recovery. So, hope that was a educational video for you.